hadn't gotten this far yet. And this is usually that last little bit. So, like we've done before, we would always start with our givens, figure out where we gotta go. But in this case, before I do that, look at what you have to prove. We have to prove that a definition occurred. So if something bisects a segment, what was that segment cut into? Cut into two. Are those parts equal or not equal? Two equal parts. So in order for us to say that this actually happened, we have to be able to show, well, if I'm bisecting segment JP, what two segments would have to have been congruent to each other? Very good. That means we'd have to show that JM is congruent to MP. So that looks a little bit more similar to what we were doing yesterday. This idea of proving that a definition occurs is just an extra step. It's relatively simple. It's how we set it up in the long run. So going back to the idea of how we always start proofs. How do we always start proofs? Givens. Good. So we put our givens in. JK is parallel to QP. Then according to your progression sheet, when you have a parallel, we just follow where it goes through. Now I can go that direction, or I could have gone the other direction. Doesn't matter. So if I do that, then I know I can mark a couple of angles. Remember, where it changes direction gives you the angles that are congruent. K and Q. And this is a prime example of using one letter. If two parallel lines cut by a transversal, then alternate interior angles are congruent. Now you can make a decision. There are a couple of different things that you can do. Since you've got two parallel lines, and you also notice you have two separate transversals, you can redraw your transversal to show that the other angles are congruent. Or, everybody see how we also have vertical angles? We could do that as well. It's totally up to you as far as how you would go about it. Me, I just drew parallel. I'm just going to redraw the parallel going the other way and just use those other angles. If you want to say something about the angle M, that would work as well. So if I redraw going this way, I'm getting angles J and P. Reason. Okay. Same exact reason. Next one you got then is just your segments. Put away your phone, please, unless you want to put it back in the bin. I know you can survive without it. It's not going to kill you. And do you have triangles? Yes or no? Yeah. Now, since I did both sets of alternate interior angles, the way that I have triangles congruent because of angle, side, angle. The side is between the two angles that are congruent. If I had used the vertical angles around the vertex of M, if I used those guys, I would have had angle, angle, side. So that's why it's important for you just to make a decision on what you want to set it up to be. There are more than one way to do just about all of these. So now you have to figure out your letters. So if I say K, J, M, what has to match K, J, M? Q, Q, P, M. Watch your tick marks. It has to go QPM. So up to that point, fairly straightforward. The part we added yesterday was the whole corresponding parts of congruent triangles congruent, that cpctc thing. What were you saying? I can't say that yet. In order to say that it bisects it, I'd have to figure out what segments have to be congruent to each other. That's why we were looking at it a minute ago by saying, hey, if KQ is going to bisect JP, that means that these two guys would have to be shown to be congruent. So I have to say those parts before this. And that's where the correspondence stuff comes into play. Then you would be able to say JM is congruent to PM. Oops. JM or JP? JP. This is a very common thing. Sometimes within triangles, within the proofs, you're using that corresponding parts, but at the very end, you're going to prove that some definition. And it's either going to be midpoint, angle bisector, or a segment. And if that's the case, it's just a matter of figuring out what you had to show before you can say definition of that. Okay. So you're using the whole progression still, but now you're starting with, you knew that it was a bisector, what had to be shown. So you're finishing, you're kind of going backwards from what you were doing earlier. But it's nothing that's horribly scary bad. Right? That's the idea. That's about as complex as we're going to make these. Same idea. Say we have one like this. Side I was an artiste. Let's try something like that. Same basic idea. Now we're going to want to do an angle bisector, a midpoint, a segment bisector. Try and do an example of all three possibilities of an angle bisector. So notice you're starting with you've got your midpoint of AD. You've got a pair of angles that are congruent, and it wants you to show that that B is also the midpoint of EC. So if you're going to have to show that you have a midpoint on a different segment, that means at some point in time we have to show that those two smaller segments that make up EC are going to be congruent. So you go through the start. Where do you always start proofs? Given. Right. B is a midpoint of AD. And like I had mentioned this to you guys yesterday on numerous occasions, we have to get better at diagrams. You have to get better at marking them. You can't willy-nilly just look at it and say, oh yeah, it's going to be fine. You have to physically mark the diagrams to understand what parts are matching up with what parts. That's where most of you guys are making your mistakes. Because you're not seeing the visual aspect to it. So if I know that B is a midpoint, my progression sheet says some segment is congruent to some segment. Well, I got to look for the segments. B is the midpoint here and here. So like you just said, AB and BD. Definition of a midpoint. Oops. That's the only thing I can do off of that progression, because that's the only thing my sheet tells me that I can do. Kind of convenient that it tells you what to do. All right, so that means you go to your next given. The next given says angles E and C are the same. So I'm just going to go ahead and do this. E and C are the same. So now I have to think about which one of the 5 ways are we going to be able to prove the triangles. We had side, 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 angle, side, angle, side, angle, 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 side, and every once in a while you come across a thing called hypotenuse leg. Right now you have an angle and a side. Having an angle and a side, that means it's probably one of these 3, because I know we don't have any right angles in this case. So I either have to find another side or I have to find another angle. What am I going to find? The angle. Very good. Here I'm going to have to get those vertical angles. I'm going to look at it right now, and I know that I have to say something about those angles right there because of the bow tie. That's where they cross each other. Right? So we know that if I label it, if I say angle ABE, following the lettering, following the tick marks, what has to match ABE? Very good. DDC. Reason, vertical, angle. Okay. Are the triangles now congruent? You guys sound like you're all going to die. All right. Jeez. Sneezes, and no wonder why you were sick. Sneezes and coughs. And... Which of the 5 possibles do we have here, guys? We have angle, angle, side. Very good. All right. We have angle, angle, side. Now, again, this is also where you guys have made mistakes. We just spent an extra 30 seconds making sure we wrote the lettering to match on those angles. We watched to make sure that tick marks match with ABE, segment, double, single, segment, double, single. We made sure that those angle tick marks matched. Will those letters still hold true if I put a triangle symbol in front of it? Yeah. Now that's the other thing. A lot of you guys aren't putting symbols in front of stuff. You have to put a symbol of what you're talking about. And there you go, your angle, angle, side. From there, knowing that we have to prove that E was a midpoint of EC, I have to figure out what 2 segments had to be congruent to each other to make that work. Very good. And why would you say those are congruent? Very good. So it was EB congruent to CB because corresponding parts of congruent triangles are congruent. Therefore, B is the midpoint by definition. Yesterday, we talked about that all day yesterday. Yes, sir. I went, for EB and CB? I wrote it EB, CB, inward. I see what you're saying. I'm not, for doing the midpoint segment stuff, I'm not yelling about it, I'm not worried about it, because those are all right. When we line up angles, you have to make sure the directions go. I went the same way, went out in. If you wrote EB, continue on BC, that's okay. There's a little symmetric into that. for midpoint and segment-wise, there's not that big of a deal. But angles, you've got to be careful because then you mess up the triangle. Yeah. Yes, sir. After, did you guys watch the video? Well, it's what they're there for. Anyway, so the idea here is, once you have triangles that are congruent, if you think about it, when we show that we have triangles congruent, you either have all three sides, two sides and an angle, two angles on a side, two angles on a side. Which means here, there are three angles left to talk about. There's one side and two angles. One angle and two sides. One angle and two sides. Once I have all this congruent, then I can say, oh, that other angle is congruent to the other angle because they have to correspond to one another. There are other sides that have to correspond to each other. So if you go back up to here, right now you've got the two triangles that are congruent to one another because of, what did we say, it was angle, side, I believe? That doesn't show up here. So if I follow through here, we know that those two triangles have segments DB and AB congruent. Angles ABE and CB or DBC are all congruent. E and C are congruent. Since those triangles are congruent, the rest of the parts that correspond to one another by watching the lettering, as we said, that, we know that the letters match up because we've already said that E, it's not CDE, it's CD, wait, I wrote that wrong, A, B, so it's DBC, sorry about that. So angles A, see how angles A and D would have to match because they're first letters? So I could say that angle A and angle D have to be congruent because corresponding parts of congruent triangles are congruent. I can say that segment AE, first last, corresponds to segment DC, first and last, because corresponding parts of congruent triangles are congruent. Yep. So once you have congruent triangles, all the corresponding parts match. That's what that means. All right. So in all honesty, it's adding one step past congruent triangles. And then what we're doing right now is adding one step past that to prove something else.
So these letters have to be the same thing.
Yeah, you got to match them up.
It could be like B or EB and BC.
For segment-wise, it's not the end of the world, but when your angles, it has to match because they pass through too many things. Let me show you now. Yeah. So this one here, we've got segments ZY and XY are congruent. Angles WYZ is congruent to angles to angle WYX. I want to prove that YW bisects ZWX. Right? Getting the triangles to work here is the really, really, really easy part. I start writing out my givens and I start filling in my blanks, as you start filling in your blanks, as you start filling in your proof itself, this becomes very evident as far as what you need to do. This really matches what you guys did last night for homework. The 4 proofs I had for you guys last night had no progressions. They really only had left over in a reflexive step. That was it. So if you start this one through, again, always start with givens. And mark. Go to the next one. Angle WYZ. Angle WYX. Mark it. You have an angle and a side. What's the most obvious thing that you can do now? Shared side, the reflexive side. Very good. I've got the reflexive part. Okay. Very similar to what we did yesterday. Very similar. YW, congruent, YW. Why are the triangles congruent? Excellent. Side, angle, side. Now, one of the things I've been trying to get you guys, comfortable with is anytime that you're given angle letters, reuse those angle letters as the triangle letters. Because if they're given to you, they're going to be in the correct order. That means less thinking. Okay? The letters that were given to you, WYZ, WYZ, that's a triangle. WYX, that's a triangle. Use those letters. And reason would have been what? Side, angle, side. What do they want you to prove? Okay, so it wants us to prove that an angle got bisected. Well, in order for an angle to be bisected, that means 2 angles had to have been congruent. What are the 2 angles that have to be congruent? XYW, what'd you say? XWY and good. I want to see what your next letter was. Yeah, I don't know if you guys heard. She goes XWY. Has to match. ZWY. Now, would it have been okay to say angle YWZ, angle YWX? Yeah. Just flip your front and back letters. It's okay. As long as it's consistent, that's fine. You just have to be consistent. So now we've shown that that large angle got cut into 2 congruent parts. Which means now, what can I say? YW bisected. I'm just working backwards off of the definition. YW. Oops. ZWX. And that was definition of an angle bisector. That's as complex as we get into this stuff, to be honest with you. There's no need for us to get any fancy. Here, this one so you don't have to draw it. So real quick. Ladies and gentlemen, I want you to take this opportunity to do number 4. We'll talk about it in a minute. Have your progression sheet out. Follow progressions. Look at what we have to prove first. So that way you can understand where you have to go with it. Okay. Let's start with that 4th one. No, thank you. Don't worry about the lines, guys. It's sometimes you need all the lines, sometimes you might need an extra one in there. It was just thrown in there. The person that made this one just put a bunch of lines in it at one point in time. I just never got rid of it. It's no worries. Okay. Yeah, that number of lines does not mean number of steps, so don't worry about that. Take a second and roll through that one, and we will check it here. With time-wise here, start your given, mark it, next given, mark it. What's left? Reflexive. Throw your reflexive in. For those of you guys who are just using single tick marks on every single segment, stop that. It doesn't. You can't do that. You have to have different number of tick marks for different things that are equal to different things. Okay? Because on your sheet, if you have 1 tick mark for segment AC and 1 tick mark for BC and 1 tick mark for DC, that's telling me that all 3 of those are the same. Well, guess what? They're not. Okay? Nothing that says that they are. You can't just assume it. Because we all know there's no in math. But there's no but in math. Sorry. Again, now we know that we have triangles. We're going to reuse whatever letters they give you for an angle. It'd be really hard pressed to screw that up. So you couldn't, but more difficult. You have side, angle, side. This proof wants us to show that an angle got bisected. Well, we need to say what angles were congruent then if they were to be bisected. So you follow it. AC bisects the angle up here. So we know that angle CAB is congruent to angle CAD because of the corresponding parts of the triangles are congruent, which therefore means that AC bisected. Bless you. Okay. And that's where that goes. Finish this for tomorrow. Tomorrow we will do isosceles and equilateral triangles. No, just isosceles and equilateral. We're not worried about scaling stuff. We're not classifying anything right now. When we get into those, there's going to be one progression for either one. Super simple. It's not that it shows up very often in terms of proofs, but it is something that we use a lot of times with algebra. So if you haven't been bringing a calculator, make sure you bring a calculator tomorrow. We'll be using more math over the next day or two versus the proof, but it's not to say that we're done totally with proofs. We still got a few days left, okay? Oh, you want to continue on with proofs? Not necessarily. Usually this is the last bit of the proof. There are a couple of proofs on the final, but those are usually some fill in the blank or multiple choice stuff. What's that? No. Because it's multiple choice, it's all you should be able to look at the diagram of the part. That's that. Remember the worksheets we were doing yesterday? Or I'm sorry, on Monday, once you guys did when I wasn't here, where you had to mark the diagram, figure out what method it was. So it's pretty easy. Or if they give you a step, you can tell the reason, especially if they're all listed there. Next one is segments within triangles. It's a lot of math. It's a lot more formula stuff. So we got that, and then we finished out the semester with quadrilaterals. What's that?